All right, guys, welcome to our AP Statistics Online review for Part 9. Give me 1 second and I'll get this started. Okay, so we're back, and so I'm going to go through. We were able to get through those 5 sections yesterday of the AP Statistics probability review, and we'll take a look at some of those. The first was general probability. That was 4.1 as a general probability. The second one was 4.2 binomial distributions. 1 second. Stop again. Okay, so here we are. So I've got video. So in 4.1, it was general probability. And with general probability, we talked about, let me share my screen with you. We talked about define or and probability, which is mutually exclusive and independent. So we talked about if things are mutually exclusive, to define if they're mutually exclusive or not. If they're not mutually exclusive, which means they can occur at the same time, then you would add your probabilities together and subtract where they both occur. If they are mutually exclusive, where they do not occur at the same time, if they are not done at the same time, then if they are mutually exclusive, yes, then the probability of A or B is the probability of A plus the probability of B. So if they are mutually exclusive, the probability of A and B is actually equal to 0. Their probability of A and B is equal to 0, as far as that goes. Now, the next thing on here, as we go through, hold on one second. The next thing, if you go through, if they're independent, the probability of A and B is A times the probability of B given A. And if they're not independent, and if they are independent, we can just multiply the probability of A and the probability of B. Okay, so that was general probability. Then we went to binomial distributions, where we talked about to be a binomial, they have to be binary, meaning two options. So there's just two options, success or failure. They have to be independent. They have to have a set number of trials, and they have to have the same probability. And then we talked about transforming and combining random variables, and when we talk about combining random variables, when you multiply or divide by that variable, you can multiply or divide to get the mean, standard deviation, and the variance you would multiply or divide by A squared, because the variance is the standard deviation squared. When you add or subtract, you would add or subtract the actual mean, but the standard deviation and variance would not change at all. Okay? Combining random variables, if you add, then obviously you're going to add the mean together. If you subtract, you're going to subtract the means together. But with your standard deviation and variance, you're always going to do the same thing. You're going to take your variances and add them together. And for the standard deviation, you would be doing the same thing. You would just take the square root of that. So it doesn't matter if you add or subtract, you're always adding down there. In 4.4 normal distribution, you have a mean and you have a X value here. You have to find your Z-score. Remember, for Z-score, it is X minus the mean divided by the standard deviation. That gives you a Z-score of 1.25. And then normal CDF would be giving you the area. This said more than, so we went from 1.25 to 999. If it would have said less than, then we would have went from negative 999 to 1.25. B, how many views would be in the bottom 5% of all days? To do that, you have to go to inverse norm 0.05, and you get a Z-score for the bottom 5%. That's negative 1.645. That's your Z-score for the bottom 5%. And then you want your mean and your standard deviation. And so you're going to end up solving for X. You would multiply 4,000 to both sides and then add the 15,000. That's normal distribution. Then we get to geometric. Geometric looks the same as binomial, except for bins, you see BIF. So F, instead of the number of trials being a fixed number, it is the number of trials until the first success. Okay, so instead of the number of trials until that it's over, it's until the first success. Okay, so binary, independent, the how many until your first success, and then you have to have the same probability of success. If you're describing a distribution, a binomial is always normally distributed, but a geometric is always right skewed. Okay, so the center is the same and the variability is the same. Okay, so B, find the probability that it takes Michael 4 flips until he lands the bottle right side up. That is the probability that it takes him exactly 4 flips. So that is a geometric PDF because we want to find the probability that it takes exactly 4 until he lands the bottle right side up. So that would be the probability that X equals 4. So that is a geometric PDF. Your probability here is 0.35. That came from the problem, and you want exactly 4. And then C says find the probability that Michael lands the bottle right side up within the first 4 flips. So somewhere within those first 4, 1, 2, 3, or 4, what's the chance that he lands the bottle right side up? So we do a geometric CDF. We have 0.35 as the probability and 4. So that would be the probability that he lands the bottle right side up within the first 4 flips. So that is 0.8215 would be C. Okay, so that takes us through all of Unit 4. So let's look at one of the Unit 4 free response questions. So this is Unit 4 free response 2017 question number 3. So it says, a grocery store purchases melons from 2 distributors, J and K. Distributor J provides melons from organic farms. The distribution of the diameters of the melons from distributor J is approximately normal, with a mean of 135 millimeters and a standard deviation of 5 millimeters. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137? Okay, so as we go through part A, we know it's approximately normal, so we know we can use a z-score. So z equals x minus the mean divided by the standard deviation. And so in this, we're going to say z equals greater than 137. 137 is our x. The mean is 133, and the standard deviation is 5. That would be 4 over 5, which is 0.8. Now, it wants to be greater than that, so we're going to do our normal CDF. Our z-score is 0.8, and we want to go to infinity, which we're going to put as 999, right? So we want to go greater than or equal to. So we're going to go in our calculator. So we would get our calculator pulled up for normal CDF. And I'm trying to pull up my calculator now on the computer. So I'll pull my calculator up now on the computer, and it goes from, let me share it with you. So I pull my calculator up, it goes, we take the normal CDF, so second distribution, normal CDF, from 0.8 to 999. And we paste that, and that gives us a probability of 0.2119. There's about a 21% chance that the melon will have a diameter greater than 137 millimeters. Okay, so you got there that there's about a 21% chance there. Why would you use the z-score as the lower bound? Because basically the z-score, that's the lowest you want to go, because the diameter needs to be greater than 137. So that's the lowest you want to go, is a melon with 137. A melon that has a diameter of 137 is a melon with a z-score of 0.8. So 0.8 is the lowest we want to go, because 137 millimeters is the lowest we want to go. And we want to know the probability that it will have a diameter greater than that. So the lowest we want to go is to that melon with that has a diameter of 137, the z-score of 0.8, and we want to go all the way to infinity. Okay, so we want to go greater than that. Now, part B is a little bit trickier here. Part B talks about, it says distributor K provides melons from, let's see if I can fix this. Distributor K provides melons from non-organic farms, and it says the probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137. For all the melons at the grocery store, 70% are from distributor J and 30% are from distributor K. What's the probability that the melon will have a diameter greater than 137? So what we're going to do is make a tree diagram. We're going to say, here are all the melons. Let me scroll down just a little bit and make sure you can see that. So I'm going to say, yep, there we go. So I'm going to say, here are all the melons. And I'm going to say, here's distributor J. And then I'm going to say, here's distributor K. And then I'm going to give my final probabilities. Now, distributor J, we just talked about the probability that the melon will have a diameter greater than 137 from distributor J. That is actually right here, 0.2119, which means the probability that it won't is 1 minus that. That's 0.7881. Okay? The probability that it will have a a diameter greater than 137 from K is 0.8413. So the probability that it won't is 0.1587. So if you notice, all these probabilities are added up. Okay, so this is if it's greater than 137. This is if it's less than or equal to 137. This is if it's greater than 137. This is if it's less than or equal to 137. So now we want to take our probabilities and multiply them to get our final answers down here. So the probability of the melon coming from distributor J and being greater than 137 is 0.7 times 0.2119. And that gives us 0.1483 out here. 0.7 times 0.7881 is 0.5517. 0.3 times 0.8413 is 0.2524. And 0.3 times 0.1587 is 0.0476. Okay? So you take those four, and now what we're going to look at, let's read the problem. For a melon selected at random from the grocery store, what's the probability it will have a diameter greater than 137? Well, let's look. These are greater than 137 that come from K, and these are greater than 137 that come from J. So if we add those up, 0.1483 plus 0.2524, then we get that there is about a 40% chance, 0.4007, of them being from of the melon being over 137 millimeters. Okay, so really the goal would be to kind of fill in your works. If you notice, it says 70% are provided by distributor J and 30 by K. So that's where I got the 70 and 30. The over 137, that came from up here, the 0.2119. That was the probability that if we come from distributor J, it's over 137. That came from the earlier problem. And this is 1 minus that. Then down here, the probability that's over 137 from distributor K is 0.8413, and then this is 1 minus that, okay? And so then these are all the final probabilities. So the chance that it comes from distributor J and is greater than 137 is 0.1483. The chance that it comes from distributor J and is less than or equal to 137 is 0.5517. The chance that it comes from K and is greater than 137 is 0.2524, and the chance that it comes from K and is less than or equal to 137 is 0.0476. All right. C says, given that a melon selected at random from a grocery store has a diameter greater than 137. So if we're given that, that is our denominator. The melons that have a diameter greater than 137. That's going to be our denominator. What is the probability that the melon will be from distributor J? Well, these are the ones from distributor J out of that. So that's 0.1483 over 0.4007, which gives you 0.3701. And so there's a 37% chance that the melon will be from distributor J, given that it has a diameter greater than 137. So anytime you're given some information, that is now your denominator. So your denominator is now, that it is greater than 137, and then this is your probability. Okay. So that was part C. So that is the Unit 4, 2017, number 3. So let me show you how this would be scored real quick. I'm going to take you to a brief scoring part, and then we're going to go to the other free response question, okay? Let me take you to the scoring. This is on Unit 4 probability at the Stats Medic here, and I am going to show you how this would be scored. So that was part C. Quick, I'm going to take you to a brief scoring part, and then we're going to go to the other free response question, okay? Let me take.
Hi, this is Luke from the Stats Medic, and in this video we're going to talk about 2017 AP exam question number 3. So I'll first remind you of the question, then I'll take you through the model response, and then we'll take a look at how the rubric can be used to grade it. So let's start with the question. A grocery store purchases melons from 2 distributors, J and K. Distributor J provides melons from organic farms. The distribution of the diameters of the melons from distributor J is approximately normal, with a mean of 133 millimeters and a standard deviation of 5 millimeters. Part A. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137? Distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137 millimeters. For all the melons at the grocery store, 70% of the melons are provided by distributor J and 30% are provided by distributor K. Part B. For a melon selected at random from the grocery store, what is the probability that the melon will have a diameter greater than 137 millimeters? Part C. Given that a melon selected at random from the grocery store has a diameter greater than 137, what is the probability that the melon will be from distributor J? So let's take a look at the model solution. In part A, this is simply a normal distribution calculation, and there's a couple of different ways that students could arrive at the answer, one of which is by calculating a z-score and then using the table to turn that into an area. The other option, of course, is to use normal CDF on the calculator. In part B, we have to calculate the probability that the melon is greater than 137 millimeters. Now, it could be that it came from distributor J or distributor K. This is a classic example where a tree diagram is the perfect strategy for solving this one. Now, you do have to notice that your answer from part A has to be used in one part of the tree diagram. And in the end, there's 4 different possibilities, but only 2 of which where the diameter is greater than 137. So we're going to take those 2 probabilities, add those together, get a final answer of 0.4007. Now, part C is actually asking for a conditional probability here. So given that the diameter is greater than 137, how likely is it that it came from distributor J? So we actually have to take our answer from part B, and that goes on the bottom of the fraction. On the top of the fraction is our 0.1483. Divide those out, gives us our final answer of 0.3701. So let's take a look now at the rubric so we can decide how to grade this particular question. So the way that this one is graded is it's graded in 3 parts, and for each one of the 3 parts, you're either going to get E for essentially correct, P for partially correct, or I for incorrect. And it's graded by part A, B, and C. So in part A, there are 3 components that are necessary for full credit. The first component is to establish normality and the parameters. There are several different ways that you can do this. First of all, if you use this notation somewhere, that is acceptable for establishing normality as well as the 2 parameters. Another way that you could get credit for this is by calculating a z-score. It makes it clear that we're using a normal distribution, and then we have identified the parameters here, 133 and 5. And finally, the third way that you could get credit for this is using the calculator command, where you've established normality here and you've taken care of the parameters here. Now, for component 2, you have to establish the boundary value and the direction. And there's a couple of different ways that you can arrive at this. First of all, if you have a picture, you have established your boundary value here, and then you've also established the direction by the shading here. Another way that you could establish the direction is using a probability statement. If you said the probability that x is greater than 137, there you have established your boundary value as well as the direction. And then finally, if you use normal CDF, this is where we identify the boundary value, and by stating this value here, we are also showing the direction. So it is important to notice that this notation here with normal CDF, if you have identified lower, upper, mean, and standard deviation, does in fact give you component 1 and component 2. Component 3 is just for having the correct answer of 0.2119. So if you have all 3 of those components, you would grade that as E for essentially correct. 2 components gives you a P for partially correct. Now let's take a look at part B. For part B, in order to get full credit here, you have to have the correct probability plus work shown. So obviously, here's our correct probability. Now, what has to be shown in order to get full credit for work is 2 things. Multiplication and addition. So this value right here was actually established by multiplying these 2 together. So you either have to explicitly show that these 2 values are being multiplied, or if you have a tree diagram, then that multiplication is implied. The other thing that has to be shown is this addition. And this was actually a bit of controversy at the AP reading, but it must be shown that these 2 values are being added together in order to get full credit for work shown here. Now, partial credit would be that you maybe set up your tree diagram, but you used some of the wrong values and gave the wrong answer. Or if you just simply had the correct answer, but you didn't have any work to support it. That would be partial credit. And then finally, part C, in order to get full credit here, you really have to have correct probability plus work. This one's pretty easy to grade. Here's the correct probability. The work that has to be shown is the division of this value right here divided by this value right here. Now, one other important point here is that if you had made a mistake, say in part A, and you got the wrong answer here, and then you carried that answer down here, you could still get credit for part B, even if your answer was wrong, but it was based on an incorrect answer from part A. And that same reasoning applies to part C. So once you've graded parts A, B, and C, let's now take that into a score out of 4 points. So if you have an E for all 3 parts, that would be a 4. If you have 2 essentially corrects and 1 partially correct, that would be a 3. A 2 would be 2 essentially corrects, or 1 essentially correct and 2 partial correct, or 1 essentially correct and 1 partial correct, or if you had 3 partially correct. And then a 1 would be if you had 1 essentially correct, or if you had two parts partially correct.
Okay, so let me come back to you on here. There was a lot there, so if you'll turn with me to, we're going to skip through the multiple choice for now, and I'm going to let you try to do that on your own since there aren't any multiple choice problems on the exam. And let's go to the Unit 4 practice free response questions. That should be the last part of your packet. If you're looking on the Stats Medic, that should be one of the last pages in Unit 4, okay? And I've already kind of set up the problem for you down here, but let's go. And can you let me know if you found that page? Okay, great. I do want you to know that Phase 4's packet pickup is actually on Monday for Phase 4. And I'm going to describe a few things about that to you a little bit later. But in Phase 4, you're only going to have 4 days, obviously, and then on May 22nd is the AP exam. But I have put the papers for Unit 5, Unit 6, Unit 7 in there. And then I also printed off for you the required documents from the College Board for your exam. So those required documents were the required documents from the College Board for your exam were the keyboard sheet that shows you how you would type a symbol into the computer, and then also the formula sheet that has all your formulas that you could use. So I've printed those off for you, so you wouldn't have to be actually looking at them on the computer. You could have them laid out. Another thing that you might want to do before the exam is just take these free response questions that we've done from each unit and kind of have them laid out, maybe from Unit 1 through 7, just the free response part, and have them laid out. And that way, if you see a part of a question that matches something like that, you could go to it really quickly and see how we did a problem that way. The last day of school is the 22nd, yes. So your AP exam is the end of school. So you'll be able to finish it off strong with taking the AP exam there. You should get an email or be able to locate your e-ticket in AP Classroom on the 20th. So I'm hoping that on the 20th we'll get together and make sure that everybody's able to get their e-ticket there on the 20th. I went through the responses also before I do this last one. I went through the responses on the time for a practice exam, and a lot of people have been working, they wanted a practice exam, and the responses were pretty varied in that people had different times. But what the number one time, so I'm going to look and explain to you. The top time that was selected was Monday at 12 p.m. was the number one time. And I think 8 people selected that. Now, packet pickup is like 1 to 3 on Monday, so it wouldn't interfere with that. Monday at 12 was the highest time. There were 8 people that, or out of the total, like there were many more that responded, but it had the highest number of people who picked it. Now, what I will do though is, so Monday at 12 is going to be the practice exam, and I'll send out information about that. That'll be on Zoom. But what I'm going to do is I'm going to make sure that that is recorded as well, and that if Monday at 12 did not work for you and it's impossible for you to make, then you actually can do it on your own at any time. Okay, so I'm going to make sure I record that to where if you just go to that video, it will take you through the practice exam, okay, and all the questions, and then how to do it at the end, an explanation of the answers. So I'm going to be working on making that recording on YouTube, and making that available to anybody that wants it, even though they can't make the live stream, Monday at 12 o'clock. Okay. So you let me know. But right now, Monday, our session, I'll send out a schedule for next week. But right now, Monday, we're going to do a 12 o'clock session, and that be our practice exam. And then on Tuesday, we're going to look at Unit 5, the free response questions only from Unit 5. We're going to go through the videos and then the free response questions from Unit 5. On Wednesday, we'll go through the videos and the free response questions on Unit 6. And then on Thursday, we'll go through the videos and the free response questions on Unit 7. And then all throughout that week, this last week, I can take any questions on your if you have any questions about the exam, I'll be able to take those. I think that practice exam on Monday will kind of help you see how it's going to be set up and what it's going to look like, and kind of like how would the two questions work and how much time am I going to have. So I think it's a great idea to take that practice exam and kind of see that first. That way, when you get into the exam for the first time from some other classes, I've heard that they've been kind of overwhelmed just because they're not used to it and they're not used to the platform and how to use it and things like that. So I'm not used to taking that exam online, and especially when you only have 45 minutes. So we're going to try to get you used to that by taking the practice, and then we'll we'll give you some help and make sure you know all the answers to that. And then what I would use on exam day would be, I would obviously have my e-ticket if I could print that out or write all the information down from it. I would want to have my formula sheet and that keyboard instructions. I would want to have Google Docs or whatever I'm going to use pulled up so that I can be typing and then copy and paste. And then there's an exam day checklist that we'll go through as well. Okay. So Monday, 12 o'clock will be our practice exam. So let's go back now to this question. The Big River Casino is advertising a new digital lottery style. The Big River Casino is advertising a new digital lottery style game called Instant Lotto. The player can win the following monetary prizes with the associated probabilities. There is a 5% probability to win $10. So to win $10, you have a 5% chance, 0.05. Okay. There is a 4% probability to win $15. So that's 0.04. There is a 3% probability to win $30. That's 0.03. There is a 1% probability to win $50. So that is 0.01. And then there is a 0.1% probability to win the $1,000. So that is 0.001. Okay, to win the $1,000. Now, as a promotion, a visitor to the casino is given 20 free plays of Instant Lotto. Now, one thing I'm missing real quick is, what's the chance of not winning anything at all? What would be the chance of not winning at all? So they give us the probability of winning, but what's the chance of winning $0? So can you add those up and subtract them from 1? 0.859 or 0.869? Which one do we get? So this is 9%, 12%, 13%, just over 13%. So I think it's 0.869. Is that right, Jacob? I think it's 0.869. Yeah, okay. So that's the chance of not winning at all. That's fine. Almost 87%. So you want to, to check your work, you want to make sure all the probabilities add up to 1, and when they do, that's great. As a promotion, a visitor to the casino is given 20 free plays of instant lotto. What is the probability that the visitor wins some prize at least twice in the 20 free plays? We want to know what's the probability the visitor wins some prize, we don't care what prize it is, at least twice during the 20 free plays, okay? So we're going to look at, the first thing we're going to look at is in in A, before we go to that one, A wanted us to calculate the expected value. So expected value is X times the probability, and you add. So it would be 10 times, so 0 times 0.869 is still 0, right? So I didn't include that. So 0, you could put it 0 times 0.869, but it's 0, so you don't really have to include that. So 10 times 0.05 plus 15 times 0.04 plus 30 times 0.03 plus 50 times 0.01 plus 1,000 times 0.001. That equals $3.50. So that's the expected value of the prize for one play of the instant lotto. Expected value is $3.50. Okay, that's our expected value. Now, as a promotion, a visitor to the casino gets 20 free plays. So that's they're giving them a free chance here. What is the probability that the visitor wins some prize at least twice? So at least twice means probability that is greater than or equal to 2, right? That they win at least twice, 2 or more times in the 20 plays. So the probability that X is greater than or equal to 2 is the same thing as 1 minus the probability that X is less than or equal to 1. Okay? Now, so the chance that they win in just one prize, so we want to find the probability X is less than or equal to 1. So we would do a binomial CDF. Oops. So it would be 1 minus a binomial CDF of them winning up to one prize. So the chance of them winning one prize is, you add up all these chances, and you get 0.131. So there are 20 free plays, and we have 0.131 chance of winning, and winning up to one prize. So what you're doing is you're taking away, what you're doing here is you are taking away the chance of them winning up to one prize. So if you want to know the probability that they win at least 2, you do 1 minus the probability they win up to 1. That means the chance that they win no prizes or one prize. You get rid of that, and what you're left with is the probability that they win 2 or more. So we're going to go to our calculator real quick, and we go to binomial CDF. So 1 minus second distribution, we're going to scroll down to binomial CDF, 20.131 and 1. And you get a probability of 0.7579 if you round that to 4 decimal places. So there's about a 75% chance of winning some prize at least twice. So I would write, the visitor has a 0.7579 probability of winning some prize at least twice, some prize at least twice in 20 plays. Okay, that's B. So now we're going to go down to C. The number of people who play instant lotto in a day follows an approximately normal distribution with a mean of 800. So I'm going to draw a normal curve, and I'm going to put the mean right in the middle of 800 and a standard deviation of 310. Okay? It wants to know what is the probability that a randomly selected day has at least 1,000 people. So at least 1,000 means 1,000 or more. So 1,000 would be somewhere over here, and you want 1,000 or more. So I'm going to shade over this way. Okay, so the first thing that I want to do here is a z-score. So I'm going to say z equals 1,000, because that's our number, minus 800 divided by the standard deviation of 310. So that's 200 divided by 310. Okay, that is going to be a z-score of, it says 0.645, which we round our z-scores to 2 decimal places. So 0.65 is our z-score. And we want the probability that the z-score is greater than or equal to that, right? Because we want it has at least 1,000, so greater than. So we're going to do a normal CDF from that z-score of 0.65, that's our z, all the way to infinity, which is 999. Okay? And so now we can go to our calculator, and we'll go to the normal CDF in our calculator. We'll pull that up, and we'll do second distribution. We'll go normal CDF. We'll go from 0.65 to 999, and we get 0.2578. I'm going to write that down at the very bottom. That is our probability. So we get 0.2578. So what that means is there is a 0.2578 probability that a randomly selected day, I'm getting this from the problem, has at least 1,000 people play instant lotto. So let's go back through this problem really quickly. If you look back at this problem, what you'll see at the beginning is it gave you the chances of winning. What you needed to fill in was the chance of not winning. Then you had to do the expected value. So that's x times the probability plus 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 x times the probability. That gives you what's called the expected value. That's how much you're expected to win when you play the game. Now, expected value can also be called the mean. A lot of times they like to talk about that as the mean. So as a promotion, a visitor is given 20 free plays of instant lotto. So we want to know what the probability is that they win some prize. It could be anyone. It could be the $10 one. But some prize at least twice in the 20 free plays. So to know that they win at least twice, so 2 or more times, we're going to go 1 minus the chance that they win 1 or less. And so the chance they win one or less, well, there's 20 free plays. The probability of winning some prize, if we add up all the prizes, is 0.131, and we want them to win up to 1. We want to take away the chance of them winning up to 1, 0 or 1 prize. And so we get 0.7579. That's what we're left with. So that means the visitor has a 0.7579 probability of winning some prize at least twice in the 20 plays. Then we get to the bottom where it says the number of people who play instant lotto is approximately normally distributed with a mean of 800 and a standard deviation of 310. What is the probability that a randomly selected day has at least 1,000 people play instant lotto? Well, because it's normally distributed and because they give you the mean and standard deviation, we know we can use the z-score. And so we get a z-score of 0.65. We want to know that at least 1,000 people play it, the probability that at least 1,000 play it. So that would be this or more. So we go to normal CDF, we put in our z-score, and we go to infinity because we want more, right? If it was less than 1,000, we would go from negative 999 to 0.65. But because we want more than 1,000, we're going to go from 0.65 all the way to 999. And we get a probability of 0.2578, and then we respond in words about what this means. It means that there is a 0.2578 probability that a randomly selected day has at least 1,000 people play the instant lotto. And that's what we mean there. Okay, so I've taken you through both free response questions, the Unit 4 free response 2017 number 3, and I've taken you through the Unit 4 practice free response question. So the only thing we didn't do in Unit 4 is these multiple choice questions. Now, there are 20 of those. So if you want, you can. So I'm going to leave this kind of up to you as far as how much you want to study here. But if you want to go through these multiple choice questions, you can. And if you come back on Monday or Tuesday and have some questions with those, that will be fine. I will go through those questions. If not, we're just going to go ahead and move on to Unit 5, okay? So we're going to focus on the free response questions only because the free response questions is what our exam is. So that's going to put us at the most focused time. That's going to put us at the most focused time together, okay? So what I would like for you to plan for next week is for, and I'm going to write this in the chat. So I would like Monday, 12 p.m. is the AP practice exam. And if you're not there right at 12 p.m., you'll be behind. So I need you to try to log in to Zoom or to the links that I give you a few minutes early, okay? Tuesday at 10 a.m., we are going to do Unit 5, which is sampling distributions. Wednesday at 10 a.m., we will do Unit 6, which is confidence intervals. And Thursday at 10 a.m., we will do Unit 7, which is significance tests. Okay, and then Friday at 2 p.m. is your AP Stats exam, and you want to log in by 1:30 p.m. for that. Okay, before then, though, Monday from 1 to 3 is packet pickup, which will include all notes from Units 5 through 7 review and include the AP formula sheets and the AP keyboarding tips. Okay, so I'll be able to give you that on Monday. All right, so does anybody have any questions that I can answer before we call it a day for today? And I send this off to YouTube for recording. Does anybody have any questions about next week? It's the end. So I really think you guys that have been on, so Alexis, Emma, Gavin, Jacob, you're going to be in great shape. Like, there is absolutely nothing to worry about. Follow along next week, but you don't need to overstudy. But I do want you to do look at this stuff and follow this hour session that we're doing. Do the practice exam. I think that really will help. And I really and I can't imagine you not doing extremely well on this exam and it carrying over for college credit. So I have all the faith in the world that you're going to do well. I can't see. I mean, we've done everything. You guys have been attentive to everything, even when we haven't been in school. You've followed through with the notes and the assignments and ask questions. So if you have any questions, remember I'm available on Canvas Messenger and Remind. We may on Friday, with the AP exam being at 2, we may schedule a 10 a.m. meeting. I'll put a poll out and see if anybody's interested in that. Just a brief, like 30-minute overview, me to give you some tips and things, help make sure you're not as nervous about it. But we'll go from there, okay? So keep that schedule. I'll be sending that out on Remind and on Canvas so that you have that as well, and so that everybody can follow through. So y'all have a good weekend. Enjoy your weekend. I think it's going to be great weather. Enjoy your weekend. Try not to think about school too much, and then come back next week, and we'll end the school year on a really good note, okay? All right, have a great day.